All right, guys, we're continuing Chapter 2, Section 1, dealing with powers and radical functions. What I need you guys to do is I need you guys to put problem number 6. That's right. In your journal. Now, what makes this problem difficult?
It's 2 squares. 2 square roots.
Yeah, two radicals. Yeah. 2 radicals. So, right now we have this radical minus this radical. Are these like terms?
Yes.
No.
How are they not? Okay. They both have an x and they both have a regular number.
Right. However, if I have a radical x, all right, and I add a radical x, yes, that would be 2 radical x's. Okay? But if I have a radical 2x plus a radical x, these are no longer exactly alike. It's kind of like if you go back to Algebra 1 when you have, what's a plus a? That's 2a's. But if I say, what's a plus a times b, you can't simplify that. No. That would be, if you had a times ab, that would be a squared b. Alright? So right now, these are 2 totally unlike terms. The only thing that they have that's similar is they both have radicals. So what I want you to do first is I want you to add this radical to both sides. I'll explain why we're doing that. So right here, if I have a negative radical 4x plus 9 plus a radical 4x plus 9, that does zero out. So here's what we have left. We have a radical 6x plus 12 equals 1 plus radical 4x plus 9. Now, if I ever wanted to get rid of a radical, if I say radical x equals 8, what could I do to both sides? I could square, right? If I square, that becomes x, this becomes a 64, and you're done. So whenever you want to get rid of a radical, use square. So what I'm going to do is, I'm going to square this side. If I square this side, I also have to square what? This side. Alright, so which one is easy? The left side or the right side? Left side. What is this right here squared? What's that going to become? Why is the right side a little bit more difficult? Because I have a 1. By the way, the talking that you hear going in the background is Josiah.
It was a question that was being answered.
Oh, good. What was the question?
If I really had to divide negative 2 over 2 into calculator to make sure it's negative 1, I said yes.
Sorry. Good thing I'm not recording right now. So, oh wait, I am. So right now, what does every student need to know how to do before they graduate high school? What do you think the answer is?
Oh, boy.
Yes, thank you. Good job. So right here. If you go to a college algebra class and you don't know how to FOIL, they will make fun of you. Either in front of the whole class or in their minds. One of the other. There are students that didn't know the FOIL method. So, by the way, you're going to take this 1 and you got to multiply it to the 1 and the radical 4x plus 9. Now, Jade, I'm going to be nice. I'm going to let you go first. What's 1 times 1? There, good job. Plus, what's 1 times a radical 4x plus 9? Very good. So far, so good. Now, I'm going to highlight this next part right here in this beautiful magenta. So we have to distribute that to the 1, and then distribute that to the final radical. So what's a radical 4x plus 9 times a 1?
Me?
Yeah, go ahead.
Wait,
What's radical 4x plus 9 times a 1?
radical 4x plus 9.
That's right.
Yeah.
It's just itself.
Dun, 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 dun.
Now, Josiah, what's radical 4x plus, you made sound, which means you want to be called on. What's radical 4x plus 9 times another radical 4x plus 9?
No clue.
Go ahead, Amy.
Radical 4x plus 9 squared.
Which is?
4x plus 9.
That's right. Just remember, a radical times the exact same radical is whatever's inside. So radical x times radical x is just an x. So if I take this radical and multiply it to this radical, you get that. All right, let's add some like terms now. Here we go. Right now, we've got a 1. And we've got a 9. So together that makes, if I have a radical 4x plus 9 and another radical 4x plus, how many of those do you see? Okay? Now, see this 4x? I'm just going to put the 4x just up front over here. Just put 4x. There we go. Taking that 4x to the next one. Okay. So now we have 6x plus 12 equals all of this. All right, hopefully you guys can see how these right here become this. All right, now, let's think about this. Here we have an equal sign.
Why is it 4x plus 7? Because
Oh, here's what it is. See that 1 there? See that 9 there? Together, I combined those two guys and made 10.
you got 9 apples and you add another apple.
You know, he got that. He just didn't see it. It's okay. I didn't rewrite everything. I had to combine like him. So, right now, what I'd like to do is I'd like to isolate the radical. So to isolate the radical, what do we have to do to get this
Take the 10,
by itself?
4x and the 10 and put it on the other side.
Good. So we got to take away 4x from this side, take away 10 from this side. So I'm going to take away 4x from this side and take away 10 from this side.
No more questions about ED.
No, thank you for saying that right as I started recording. I appreciate it.
You did recording 16.
So this zeroes out. All I did was just bring this down. 6x minus 4x is 2x, 12 minus 10 is 2. Now, notice, what's a common number that you happen to see in front of you? So if you wanted to, you could divide everything by 2. Just divide.
That wasn't fun.
I know, sometimes that can be very funny. All right? 2 divided by 2, that just leaves us with 2 divided by 2, that leaves me with a. And 2 divided by 2, that leaves me with a. There we go. So, the only time I would divide by the number that's in front of the radical, the only time is if that number happened to go in to both of those. So if this was a 3, then my next step wouldn't be divide everything by 3. My next step would be what I'm about to do. My next step would be to square this side and square this side. Why am I needing to square both sides? What am I trying to get rid of?
The radical.
Thank God. So the last time I have to square both sides. Now, everybody, this is something that you need to know because it is very common in any type of standardized SAT, ACT, TSI. You need to know what the sum of squares are, and you need to know them, not have to think about them. So we're going to do some practice here. Some practice with the sum of squares. If you guys would want to make a little list, I'm going to use the most common ones. Then I'm going to go ahead and jump all the way up to x plus 7 squared. Then I'm going to throw a little curveball, and what if it's a minus? I know, super exciting. Glad you could. So right now we're going to do some practice over the sum of squares. So that automatically you know when you see x plus 1 squared, you know it's going to be x squared plus 2x plus 1. Just like, 5 times 5 is 25 without having to think of it. All right? You need to know your sum of squares and how they work without having to think really, really hard. So what's the pattern here?
Everything goes up by 1.
No. The pattern is this. The pattern is you take this number, you add it to itself, and you get the middle one. You multiply it to itself, and you get the last one. So what is 2 added to itself? What's 2 plus 2?
4x
Yes. What's 2 times 2?
plus 4.
Boom. All right. What's 3 plus 3?
6
Boom. What's 3 times 3?
plus 9.
Good. Go ahead, Raymond. You got this one.
14.
Good.
49.
Good. Josiah, go ahead. I gave you a curveball. Close?
Negative 6.
Yes.
Negative.
Close.
Positive 6.
Yes. Negative 8 plus negative 8 is a negative 16. Negative 8 times a negative 8 is a positive 64. So this is a pattern. You guys need to know all of your sum squares. Let's just do one more. Here we go. X minus 9 squared. Go ahead. Redeem yourself, Josiah. Redeem yourself.
Negative 18.
Good.
Positive 81.
Excellent. Good job. And consider yourself redeemed. Now, everybody should have this pattern and know it, not have to think about it. Should you have to do the FOIL method to be able to get those? No. All right? It saves you so much time and energy. So, right now, we have what? We have x squared plus 2x plus 1 equals x. This is a quadratic. I know it's a quadratic because I have an x squared. What do we set all quadratics to? Yes, we set them equal to 0. So let's take this and set it equal to 0. So awesome. By the way, this was not pre-recorded. I knew Bailey was going to say 0. All right? So we got to take away 4x and take away a 9. And now everything is equal to what? 0. What's my final quadratic? I have an x squared. Now what do I have? Negative 2x. Yes. Yes, minus 8. Now, Bailey, who's already taken and passed a college algebra course, she said, Mr. Moody, you have no idea. But man, you really have to know how to FOIL or factor, right? Because FOILing and factoring are interrelated, all right? They're like country cousins. So,
Country cousins. I like
country
that.
cousins are up there. Hey, if you FOIL, you better know how to factor. If you factor, you better know how to FOIL. Now, I'm going to put an X here and an X here. If you remember from last year, you remember me doing this over and over. Could you please tell me two numbers, when added together, equal the middle coefficient? And when you take the same two numbers and you multiply them together, they equal the final number. This is a process that you need to know how to do over and over and over again. So what two numbers add up to a negative 2, but multiply together to equal a negative? Dylan! Oh, no. Raymond!
Negative 4 and 2.
Negative 4 and 2 is correct.
I'm smart.
Yay! Alright, so we have x minus 4 and x plus 2. How do we check them? Is negative 4 plus 2 equal to a negative 2? Yes. Is negative 4 times a 2 equal to negative 8? Yes, it is. So, everybody, we factor these correctly. You have to know how to factor. Now, here's your final step. What number? Minus 4 is 0. What number? Plus 2 is 0.
Man, this is hard. This is a lot of work.
I know. Negative 2 and 4 are our final answers. But if you stopped the video right now and wrote that down, you would be wrong. You would want to watch the next part. Because one of these answers does not work. One of them is what's called an extraneous solution. How do we know which one works? Well, we take these answers and what do? We plug them in. Plug them in. That's right. We plug them back in. So here we go. Go to the calculator right now. I want you to hit second x squared 6 parentheses 4 close parentheses plus 12 right here minus second x squared 4, parentheses, 4. What am I doing? I'm doing our original equation. If you're not sure what I'm doing, this is what I'm doing. Alright, I'm doing 6x plus 12 minus radical 4x plus 9. And I'm checking it to see if it equals the number 1. This is our original problem, correct? Alright, here we go. Press enter. Oh, it equals 1. Guess what that means? That means this number right here, it works.
What did I do?
So let's do that. This is the next one. What am I going to plug in now to see if it works? Negative 2.
Oh, I did a plus 1.
Oops, not 2. Got to insert a negative. Here we go. Going to go second, delete. Good. You got negative 2.
Negative.
So when I plug in a negative 2 this time, what happens? It equals a negative 1, which means this negative 2 is considered to be an extraneous solution. Did we do all the math correctly? Yes, we did all the math correctly. And we found an answer to be negative 2. It's just a number that doesn't work. So it happens, guys. It happens. Sometimes you find an answer, but it doesn't work. Now, so what's my final answer going to be? That's it. All this work, everybody, all this work is for the solution set for the number 4, okay? Which is just x equals 4. So by the way, yes, you could probably take numbers and just plug it in and see which one it finally gets. You could do the old guess and check strategy for this one because it was a nice integer, okay? So you could if you had a multiple choice test, what you could do is plug it in. Or, check this out, go to y equals. By the way, you guys are going to really hate me. Okay? You're going to really hate me. Go to y equals, and what I want you to do is I want you guys to type in exactly what I type in here. 6x plus 12 minus 4x plus 9. And what do we want this right here to actually equal? We want it to equal the number 1. Now, understand, we reset our calculator. So what I'm going to do real quick is I'm going to hit second zoom, and I'm going to make sure I turn my grid lines on. I'm turning my grid lines on. And then I'm going to hit zoom 4. Zoom 4 so we can see this graph. There's my graph. There's my line. Hey, you know what's interesting? Where does it look like they intersect? Right there. Looks like they intersect at a 4. I wonder if we can check that. Sure. Hit second trace. Go down to number 5. Press enter 3 times. What does x equal to, everybody? 4. I know, that's... Sorry. Okay, let's try it again. Alright? Second trace, we're going to go to number 5. Oh, it's already done. There you go. Okay. So right now, x is equal to 4. Only crosses what? One place. Doesn't cross 2 places. Okay. So, what we're going to do now? Oh, what the heck happened there?
Oh, see, now we gotta quit class.
That was a close one. No, we're not going to quit. But we are going to go on to the next problem. All right, here we go. Next problem, everybody. Problem number 7. This is the last one that we're going to do. All right? I'm just going to get you guys started on this one. Okay? We'll let you guys see if you guys can finish it up. All right? Get you guys started. Josiah, what do you think the very first thing we're going to do with this? Right, write the equation in your journal. Very good. All right, so what do we need to do to both sides? Go ahead.
Square them.
Square it. Now, we're going to square this side, and we're going to square this side. Now, some of you might realize that x squared minus 2x plus 1 does factor to x minus 1 squared. Okay? So, some of you might go, hey, wait a second, the square root of x minus 1 squared is x minus a 1, and you might want to do it that way. But if you do it this way, it's a little bit, there's something you have to be aware of. It's a little bit tricky. So we're not going to do it this way. We're going to square both sides.
Hold on.
Okay? So if I square both sides, I get x squared minus 2x plus 1 equals. Now, what I'm going to do over here, I'm going to write 2x plus 5 times 2x plus 5. I'm just using the commutative property of addition, and just, which is this. If a plus b equals b plus a, that's the commutative property of addition. That's all I'm doing. Now let's go ahead and FOIL things out. Take 2x, multiply it to both numbers, get 4x squared plus 10x, multiply the 5 to both these monomials, you get 10x plus 25. So you have 4x squared plus 20x plus 25 equals x squared minus 2x plus 1. And because Bailey told us once, we'll just do it again. We got to set everything equal to 0, because this is a quadratic. So we got to set everything equal to 0. So I got to take away an x squared. Got to add 2x. Got to take away a 1. That zeroes out. These are all additive inverses right here. This becomes 3x squared plus 22x plus 24. Now you can still actually, this is actually factorable, everybody. This is factorable. This is more difficult to factor because of that 3 right in front of that x squared. But it's not too bad. You have to know that you're going to have a 3x and an x. If everything is plus signs right here, then you know this has to be positive and this also has to be positive. They're both pluses. Okay? Now, right now, just look at the factors of 24. The factors of 24 are 24 and 1, 12 and 2, 8 and 3, and 6 and 4. So if this is factorable, it's going to be what's going to be one of those sets. Okay? So let me show you one that doesn't work. Okay? What if I put an 8 here and a 3 there? Okay? If I put an 8 there and a 3 there, and I multiply the 3x times 3, what does that become? 9x. And I do 8 times x, what does that become? 8x. What's 9x and 8x added together? 17. What do I want? 22. I want you guys to understand, though, that the most important values right now are the outside terms and the inside terms. Now, is 8 times 3 24? Yes. Is 3x times x 3x squared? Yes. Well, we got to figure out what numbers go here and here. If I put a 6 here and a 4 there, what's 3x times 4? That's 12, right? What's 6 times x? 6x. What's 12x plus 6x? 18, that's 18. What do we want? 22. But watch what happens when you reverse them. What is 3x times? And what is 4 times x? 4. And what do they add together? So we just found our factors. We're setting this equal to 0. So here's our final factors. 3x plus 4 and x plus 6 equals 0. What number could I plug in there? -6. This one's a little bit harder to see, so what you have to do is you have to set this equal to 0. Set equal to 0. 3x plus 4 equals 0. I'm going to take away 4 from both sides. Divide both sides by 3. X equals -4 thirds. So we have two answers. We've got a -6 and a -4 thirds. Only one of them work. So if only one of them work, let's just plug it into the graphing calculator and see which one works. We're going to plug it into the graphing calculator and see which one. All right, so here's how we plug it in. Go to y equals. For y1, could you guys please type in, is it 2 plus 5x or 5 plus 2x? It's 5 plus 2x, okay? And over here, very important that you hit second x squared, type in x squared. There we go. X squared minus 2x plus 1. Now, after you set this equation to equal to this equation, then you can actually just hit graph. Where does it hit? Where does it actually hit?
So it's finding to be the best.
It looks like it's going to be that negative what? That -4 thirds. So how do you check it? Second trace number 5. Second trace number 5. What's the first curve? 5 plus 2x. Press enter. What's the second curve? All of this right here. Press enter. Now it's going to do what? It's going to guess where that point of intersection is. And where is that point of intersection? What fraction is that? -4 thirds. So which answer was the extraneous solution? Which one was extra? Yeah, that was the extraneous solution, okay? I realize, no, you don't have to. The final answer is just -4 thirds. I just want people to know that just because you do all the math correctly doesn't mean you're always going to get the answer that works. You got to find the answer that works. All right? Good job.